hier. Et donc, on va avoir 3 intervenants spécialistes du sujet qui vont pouvoir vous apporter leur expérience de laboratoire et également de terrain, y compris en Italie. On va voyager en Europe ce matin. Donc, sans plus attendre, je vais laisser la parole à Hayet Djelal pour UniLaSalle pour la première présentation, effectivement, sur le biochar comme vecteur potentiel. Alors, on va juste changer la présentation. Après, elle est devant. Ouais, elle va venir devant aussi. Ça va être plus simple, je pense. Elle va arriver tout de suite. C'est bon pour vous? Non, je ne sais pas si on les voit. Pas encore. C'est parfait.
Donc, voilà. Donc, bonjour. Je vais vous présenter nos travaux qui allient biochar et méthanisation. Alors, très rapidement, un rappel sur la méthanisation et sur la pyrolyse et la production de biochar. En fait, la méthanisation, surtout ce que je veux montrer, enfin, ce que je veux appuyer le point, c'est que c'est grâce à l'activité de micro-organismes, certes en milieu anaérobie, que l'on va avoir la production de biogaz, après biométhane et CO2, et le coproduit, donc la fertilisation. Mais on a bien des micro-organismes. Et on va avoir une succession de réactions biochimiques, partir de macromolécules jusqu'au méthane, mais aussi le CO2. Et il est vraiment important de favoriser la voie de production de CH4, par exemple, plutôt que la voie de production, parce que l'on peut le faire aussi, d'hydrogène dans ce cas ici. Et il est important de remarquer qu'il y a des paramètres qui vont impacter cette production. Tout d'abord, l'écosubstrat. On va parler, c'est vrai, beaucoup de biomasse, donc l'origine, le pH, la salinité, etc. Mais aussi les coproduits de la réaction, essentiellement avec H2S, NH3 et les acides gras volatiles, donc les AGV, qui perturbent l'activité microbienne. Le biochar. Alors, le biochar, c'est un tout autre procédé, là, qui est sans micro-organismes, mais où on va travailler aussi avec une biomasse à température, oui, bien plus forte en tous les cas que la méthanisation, un temps de séjour et une vitesse de chauffage particulière pour avoir un syngaz. Mais surtout, ici, ce qui nous intéresse, c'est un solide. Et si la matière première ou l'intrant est un bois A, eh bien, on aura le biochar. Alors certes, on peut aussi avoir du biochar si on va avec la pyrogazéification, mais comme on le voit, les rendements de production sont beaucoup plus faibles que si on a une pyrolyse douce. Alors pourquoi on s'intéresse tant aujourd'hui au biochar? Eh bien c'est par rapport à ses spécificités, la porosité, l'aire de surface spécifique, etc. On le voit. Et puis aussi, un point qui est important, c'est les groupes fonctionnels de surface, où là, on n'a pas de l'adsorption, mais on aura plutôt des réactions, par exemple, covalentes. Donc, il y a la littérature abondante sur le sujet, littérature scientifique internationale. Et le biochar, aujourd'hui, a vraiment trouvé une valeur, une application en agronomie, pour sa valeur agronomique, mais aussi pour le capture de CO2. Et là, plus un peu au laboratoire, on est vraiment dans le traitement des eaux et dans le traitement de l'air. Alors, pourquoi biochar et méthanisation d'une manière très générale? Là aussi, beaucoup une littérature scientifique de plus en plus abondante. On considère que c'est d'abord un support pour les micro-organismes, donc dans le digesteur anaérobie. Le biochar contrebalance les fortes productions d'acides gras volatiles, essentiellement donc c'est l'acide acétique, atténue l'inhibition par de NH3, absorption des éléments traces métalliques, séquestration du CO2, ça peut être intéressant après pour la qualité du biogaz produit, évidemment élimination de H2S. Et là, c'est plus en sortie, on va avoir une augmentation du pouvoir fertilisant du digestat. Et là, un point qui est intéressant, c'est le transfert des électrons entre les archéas et les bactéries anaérobies. On considère que c'est un point important pour l'activité microbienne et où les électrons vont se déplacer donc entre les différents micro-organismes sans avoir à passer par des réducteurs. Alors, maintenant, la genèse de ce projet, c'est vrai qu'au laboratoire, enfin à UniLaSalle Rennes, on travaille depuis quelques années sur la méthanisation, mais on travaille aussi sur la pyrolyse et le biochar avec Lydia Frida. Et là, l'idée, c'est de combiner pyrolyse, production de biochar, méthanisation, digestion anaérobie, toujours avec l'idée de production de gaz renouvelables. Et on a répondu à un appel à projet de la région Bretagne. C'est le dispositif stratégie d'attractivité durable où justement on proposait cette combinaison et on a été retenu. Donc on a pu développer des essais laboratoires. Donc c'est la partie expérimentale, vraiment travailler à l'échelle labo et aussi essayer de vérifier les résultats que l'on obtient au labo. Est-ce qu'on peut les transposer sur un territoire financé par la région Bretagne, donc sur le territoire breton. Alors, tout d'abord la partie expérimentale, après la partie géospatiale. Pour la partie expérimentale, nous avons travaillé avec deux digestats, avec un mélange d'intrants, le digestat d'une unité de méthanisation Castelméta, tout près de l'école, à 10 minutes, et puis les biodéchets hygiénisés du champ fleuri nord-est de Rennes. Pour les biochars, deux biochars, Terra Fertilis, Carbofex, qui se différencient déjà par rapport à la matière première ou la source, la production, la température aussi de production. Les essais ont été conduits en discontinu, sur des volumes faibles, certes, des essais laboratoires de 150 millilitres, et on a à chaque fois en intrant digestat d'une unité de méthanisation, biodéchets hygiénisés. On a travaillé avec les deux biochars bruts, mais on a voulu aussi tester le traitement du biochar en amont de l'incorporation, un traitement thermique ou un traitement magnétique, le fait de magnétiser le biochar avec une source de fer. Alors là, les principaux résultats que l'on présente, les essais ont été conduits pendant 14 jours, uniquement avec 1% de biochar, parce que de nombreux essais ont eu lieu préalablement. On s'est rendu compte que c'était le pourcentage masse-masse qui donnait les résultats les plus intéressants. En vert, là, on voit que le témoin, c'est notre témoin biodéchets, un mélange de biodéchets hygiénisés et digestats, sans ajout de biochar. Et pour ces résultats-là, on constate que l'ajout de biochar Terra Fertilis donne les meilleurs résultats. Et en plus, si le biochar au préalable a été traité thermiquement, on a encore de meilleurs résultats puisqu'on a une augmentation de conversion de la biomasse en biométhane de 30%. On va continuer les essais plutôt avec Terra Fertilis et on s'est dit, tiens, on va comparer aussi avec un traitement magnétique, donc réalisé au laboratoire. Et là, c'est intéressant. On voit que l'on a encore de meilleurs résultats, toujours comparé avec le témoin, donc en vert, biodéchets hygiénisés et digestats, sans ajout de biochar. Et on a une augmentation de 42%. Alors, pour essayer d'expliquer, on a dosé les acides gras volatiles et le titre alcalimétrique complet. On a le rapport AGV sur TAC. Et d'après la littérature, pour avoir des performances optimales, ce rapport AGV sur TAC doit être compris entre 0,3 et 0,5 environ. Et on remarque que c'est avec Terra Fertilis magnétique que l'on se retrouve dans cette fourchette, ce qui pourrait expliquer les meilleurs résultats obtenus avec le Biochar Terra Fertilis 1% pré-traité magnétiquement. Donc, ce qu'on peut dire pour cette première partie, que l'on peut ajouter des biodéchets hygiénisés, intéressant par rapport à la loi AGEC, sans perturber la méthanisation, 1% de biochar, masse, préférable de travailler dans nos conditions opératoires avec le biochar magnétique. On s'est posé la question, est-ce qu'on va avoir une modification de la composition des micro-organismes? Nous n'avons toujours pas les résultats, parce que là, on sous-traite pour cette partie avec l'INRAE, on attend les résultats. Il serait intéressant de travailler en continu avec des volumes plus élevés et des temps de séjour beaucoup plus proches de ce qui est fait réellement sur les sites de méthanisation. Alors, d'accord, c'est très bien. On voit que l'on peut, en ajoutant du biochar magnétisé, on a de meilleurs résultats. Mais sur par exemple, le périmètre d'étude de l'étude Bretagne, région Bretagne, est-ce que c'est faisable? Quelle est voilà. On va vérifier la pertinence. On a recherché de nombreuses données pour nous aider donc à répondre. Et on a pris par contre un rendement de 15%. On n'a pas voulu prendre 40%, plutôt pour être une moyenne de ce que l'on peut trouver dans la littérature. Et on est resté sur 1% masse d'ajout, donc d'addition de biochar. Alors, ce que l'on a fait déjà réaliser, les élèves qui ont travaillé sur le sujet ont réalisé une carte où on a à la fois les unités de méthanisation, mais on a aussi le tonnage estimé de biodéchets et les unités, enfin, et les hygiéniseurs. Et là, on remarque que c'est surtout au niveau donc, de Rennes Métropole que l'on a certainement une idée que cela pourrait se faire. Et les hygiéniseurs sont à environ 20-25 km des unités donc, de méthanisation. Si on applique nos différentes nos calculs, on a comme une augmentation de la production en énergie verte, donc c'est intéressant. Par contre, est-ce qu'on va trouver le biochar nécessaire? Les quantités requises, environ 50 kilotonnes de biochar par an, c'est loin d'être négligeable. Et malheureusement, sur la région Bretagne, et là où il y a le plus, je dirais, d'unités déjà de méthanisation, de tonnage important en biodéchets, eh bien, de manière pérenne, de manière de production importante en biochar, pour le moment, on n'en a pas. Donc, on a essayé de voir un petit peu plus loin à l'échelle nationale. Mais il y a le problème, c'est les distances, déjà les quantités, les distances, l'approvisionnement. Au niveau européen, c'est sûr qu'on pourrait aller encore plus loin. Ça serait possible, mais attention toujours, bien que l'addition du biochar donnerait des résultats intéressants, faudrait faire attention donc au coût du transport et à l'impact environnemental. Donc la question qui se pose, est-ce qu'il sera intéressant au niveau de la région Bretagne? Donc nous, on va rendre nos résultats à la région Bretagne d'ici 2 mois. Intéressant d'installer un pyrolyseur dans le but de produire du biochar, certes avec aussi une valorisation de la chaleur et voire le biogaz, mais où l'installer? Les coûts liés à la construction du pyrolyseur, qui va les soutenir? Le département, la région, la collectivité? Les variations du prix du biochar, du biométhane aussi, le transport et la réglementation qui a tendance à, enfin je sais pas, qui pourrait évoluer. Et puis il y a tout ce qui est acceptabilité sociale. Si je reviens à la carte de la Bretagne, pourquoi pas? Ce serait peut-être intéressant, c'est en tout cas ce que l'on va proposer, de faire une installation au niveau de Rennes Métropole où là on a l'hygiéniseur, on a les biodéchets, déjà les unités de méthanisation et une biomasse. Et un point quand même qui est très important, il ne faudra pas oublier, c'est la tension sur la matière première. Si on utilise du bois, il y a en Bretagne beaucoup de chaufferies biomasse pour la production d'énergie. Il faudrait faire attention qu'il n'y ait pas de tension. Pourquoi pas aussi un autre territoire, mais là c'est moins évident. Voilà, je voulais juste remercier la région Bretagne déjà, Patrick Bourseau, parce que pour aller récupérer les digestats. Voilà, l'aide aussi dans les discussions Aurélie Lepage et Magali Benchikoul, à la Salma qui a travaillé post-doc sur le sujet pendant 18 mois et le groupe d'élèves étudiants en génie de l'environnement d'UniLaSalle Rennes. Je vous remercie.
Merci bien, Hayet. Ce que je vous propose, alors on a 3 interventions qui sont complémentaires, mais qui sont beaucoup dans le partage d'expériences et de cas concrets, enfin de recherche et de cas concrets. Mais peut-être si d'ores et déjà il y a une question sur la présentation d'Hayet, on peut en prendre une. Et puis ensuite, on aura aussi un temps de séquence questions-réponses à la suite des 3 interventions. Est-ce qu'on peut avoir un micro, s'il vous plaît ? Si vous pouvez juste vous présenter avant de poser votre question, s'il vous plaît.
Bonjour, Christine Peyrelas pour la PESA. J'avais une question par rapport à la durée de BMP qui est de 15 jours. C'est extrêmement court. Donc du coup, est-ce que l'impact positif du biochar ne serait pas simplement lié à une augmentation des cinétiques et au fait que du coup, on tamponne finalement le milieu? Du coup, ça expliquerait pourquoi vous avez votre AGV sur TAC qui est plus élevé quand vous n'avez pas de biochar. Et au final, l'effet bénéfique pourrait être plus lissé si on avait eu un temps de test plus long.
Donc, tout à fait d'accord, il faudrait vraiment travailler sur des temps beaucoup plus longs. On avait fait d'autres essais sur 28 jours avec biochar brut, où on observait déjà une augmentation, pas aussi forte qu'avec les biochars traités thermiquement ou même magnétiques. Et ensuite, pourquoi est-ce qu'on s'est arrêté là, dans ces cas-là, à 15 jours? C'était aussi à cause de l'intrant. Et on s'est rendu compte que quand on rajoutait des biodéchets au digestat, au bout de 15 jours, on avait un plateau. Et l'agriculteur, parce qu'on a échangé avec lui, observait aussi que les temps, qu'il y avait une modification au niveau de ses résultats. Là, c'est vraiment à l'échelle une méthanisation. Mais je suis d'accord, il faudrait poursuivre les essais sur des temps beaucoup plus longs dans les conditions optimales que l'on a trouvées. Je suis d'accord.
Merci.
Pas d'autres questions tout de suite. On va pouvoir passer la parole alors avec le micro rouge. Yes, ok. Donc, Mr. Vaughan, it's your turn.
Hello, good afternoon. Thank you for coming. So I'm David Vaughan. I work for Carbogenics. I'm going to talk about our experiences with producing biochars specifically for the AD industry and the full-scale studies that we've been doing. And I've got a couple of case studies towards the end. So that's me. Don't really need to dwell on that other than to let you know that I'm a biologist. I'm not an engineer. I'm not a pyrolysis expert. I'm not a biochar expert, although I am learning a lot as we're going along about biochar. I started with Carbogenics in 2020, ostensibly to run their trials, and then I moved into R&D and business development with the AD industry. So Carbogenics is a spin-out from the Edinburgh University. It was the brainchild of Jan Mummer, who worked for the UK Biochar Research Centre at the time, and he was looking to develop carbon additives for different biotechnological applications with a focus on anaerobic digestion and wastewater treatment. But still, the overriding thing at the back of it is always about carbon sequestration and the environmental aspects. So we are looking to take difficult to recycle waste rather than using virgin wood or things like that. We're looking to use wastes and generate through the pyrolysis process these functional biochars. We're looking at anaerobic digestion and wastewater treatment, but we will look at other markets as well, such as soil remediation, farming, and a lot more recently looking at the construction industry. We work very closely with the UK Biochar Research Centre, which is headed by Andrea Marsek, again, part of the University of Edinburgh. They were established in 2029, and they do a lot of collaboration with SMEs and industrial partners. Working with them means that we do get access to their equipment, which is very useful for us. So they do have 2 stages, well, 3 stages really, but their stage 2 pyrolysis unit has an output of about a kilogram per day, and their pilot plant of about 100 kilograms per day. So we can use these in our...
Just a minute.
Right.
Just a minute. They try to modify the translation because, for instance, it's only in English. So they can't, maybe some people
Right, okay.
can't. The translation, we are waiting for a French translation. It's not okay. So maybe if you can...
I broke the machine.
Yeah,
yes,
maybe if you can speak a little bit slower,
Okay.
because
Good.
for French audience it's difficult to follow. Thank you.
Do you want me to go back a bit? Do you want me to go back
it's
a bit?
okay. You can. We try to modify the translation. You can continue.
Okay.
Please just try to.
Try to be a bit slower. Okay. Yeah.
Thank
It's
you.
fine. It's fine. My boss keeps telling me to do that all the time anyway. Yeah, so like I say, we do have a collaboration with the UK Biochar Research Centre, which is very useful for us to have it on site so that we can do a lot of the R&D work as well. We do have some of our own research facilities, so we can do biomethane potential tests. We do have small-scale CSTRs, which is where a lot of the initial work for CH4R started. So we can look at feedstock mixtures, loading rates, trace element additions, and also try and look at different biochars as well. One of the early stage trials where we started to see something with this was with a small-scale lab trial working with the wastewater treatment industry, so taking digestate and activated sludge from a site in Scotland and running it over 26 days. So you can see initially there's this kind of a stabilization process, and then once it reaches a steady state, we then start to see the impact of the biochar. So a 10% higher methane yield and a 10% reduction in CO2 and sludge coming out the other end. So this is telling us that something's going on. So how does CH4R, which is what we're calling our biochar, work with the AD microbiology? So we look at various different parameters for the biochar, which Jan, over a period of time, determined were optimal for working with the AD microbiology. So we have a porous material with a high surface area, looking at a defined carbon and mineral content. The electrical conductivity, which was mentioned earlier, assists the direct interspecies electron transfer, which is DIET, and we also do downstream processing so that the material stays in suspension in the AD tank rather than getting floating layers or sinking. And what we know is that not all biochars are created equally. Jan has done a lot of work in defining these parameters for working with AD microbiology. But if you look at feedstocks, even produced on the same temperatures and same times, you can get different feedstocks will give you different biochars. If you use the same feedstock on a different times and temperatures, you can get different characteristics from the biochar as well. And also downstream processing. The two pictures there, the one on the top is basically a biochar produced from straw, and the one on the bottom is a biochar produced from screening waste from a wastewater treatment plant. Both produced in the same temperature and time, but the feedstocks were different, and they give you morphologically a different biochar. The characteristics we're still working out. So direct interspecies electron transfer, this is something that has been mooted to be one of the ways in which the microbiology works, the biochar works. So you have microbes that need to work closely together. They can do this indirectly, transferring the electrons using hydrogen or formate, but direct transfer requires that the microbes touch. So if you have an electrically conductive material in the middle, that means that they can do this over larger distances. They don't need to touch. And this can make them much more efficient and reduce the VFAs faster. Carbogenics' approach is not an approach of we'll turn up, drop off a bag of black powder and go away. We don't want to do that. We want to work very closely with the industry. So we have a hands-on approach. We want to be data-driven. There's been so many additives to AD systems that haven't actually done what they say they're going to do. So we want to be data-driven and get all that data. So we work very closely with our clients, determines what benefits can be achieved, and then develop a personalized approach for each site. We don't claim that every site will get 30% biogas increase, because if you have a long retention time, you have a very simple feedstock, there just isn't more to get out of it. So we don't say the biochar will definitely get you more out of it, and then it comes down to how the economics work. And then we do a lot of follow-up. We regularly check in with the clients. That picture at the bottom there is how we supply the biochar. So we supply it in digestible bags, which you can just put into your solid feed hopper in the same way that you would your ferric. It's trying to take the hassle out of using this material. We do a lot of monitoring of sites. A lot of sites monitor themselves anyway, but if there's anything that's actually missing, we will actually fill in the gaps. So we do look at temperature and pH, organic loading rate, phosphatic, a very important measure. We do volatile fatty acids. We have our own laboratories, so we can look at the different species of volatile fatty acids with the propionic or acetic acid, ammonia concentrations, and the gas analysis is another important one. Looking at methane concentrations, H2S concentrations, and then look at feedstock efficiency. So essentially, what you expect to get out of your feedstock compared to what you actually get out of your feedstock. So we look at the effect on certain different parameters, and a couple of these. So pH is something else. It's something that biochar can affect if it's a highly alkaline material. Can actually get the volatile fatty acids working quicker and better and enhancing the microbiology. You can get a more stable system and less effects on the pH. Similarly with the VFAs, you improve efficiency use of VFAs, prevent that emission from the likes of propionic acid and increase the biogas output. Ammonia and H2S were two that we only really started looking at very recently. We didn't see a lot of that in the small scale work, so when we moved up to large scale, we then started to see changes in these. We're starting to see up to 20% drop in ammonia in some of the sites we're working with. And in H2S, if you look at the traditional methods to actually deal with that, such as the ion compounds and microaeration, one of the sites we're currently working with in Scotland has reduced his ferric input by half by actually putting biochar in. So the case studies we're working on, the first one is one of our early case studies where we were working with a biomethane operation, which is, I should say, 5 megawatt thermal site with 2 primary digesters working in parallel. We only fed one of the digesters, but the gas production was measured across the whole site. So what we saw was around about 2.5% increase in biogas output. The green bars show the sort of the average methane output in a meter cube per ton dry matter, and the black line is the biochar input. This was over about 6 months, but there was a gap in the middle, and that way it shows the biochar dropping off. But this was a very well operated site with a very simple feedstock, which was maize, bit of manure, and a bit of sugar beet pulp, and it had a very long retention time. So again, this is one of those sites where you say, we've getting something extra out, but is it economically viable in the long run? So we're not claiming we're going to get 20% from every site, because that's just not possible. We do some return on investments. This is based on UK tariffs and UK prices, so it's very UK centric, unfortunately. So we'd have to, if we want to work with other European markets, then we'd deal with them individually. But what we see in the UK is if this site had headspace in its biomethane capacity, it would gain benefit from that trial. What we thought at the time was that we're probably underdosing the biochar. So if we then start increasing the biochar input, obviously the price goes up, but the benefits come out. As I said, we were only dosing one tank rather than both of them, so you expect that you would double the output. One of the more recent trials that we're doing, which is actually still ongoing, is working with a CHP plant in Stirlingshire. This is a 2-stage, 1.1 megawatt site. It's a feedstock which is much more complicated than the previous site, which has a mix of distillery waste, byproducts, energy crops, and cattle manure. He's a very entrepreneurial operator, so he will take whatever comes to the door sometimes and put that in. So he can have quite a few disturbances within his system. His aim is to reduce those expensive feedstocks and try and put other things through that he will get paid for. And what we've done recently is this was the increased loading of biochar, and we see that we're getting, when we look at feedstock efficiency, so that's basically looking at what he expects to get from the biochar based on biomethane potential tests, from his feedstock rather, based on biomethane potential tests, compared to what he actually gets out. He's seen an increase in the use when he started using biochar. from 87 to 101%. Methane concentration, which is something we're only just starting to look at, and it started to kick in really in months 5 and 6, so it looks like you need to have a critical mass of biochar in the system before the methane concentration really changes. Started out around 54% and is up to 57% now. This is the same site, but just looking at the basic biogas output in meter cube per fresh ton, and he's getting quite an increase in biogas output from before the trial compared to after the trial. What he's actually started to do now is take some materials from the distilleries, which he's actually getting paid for, and he's reduced these the amount he's paying for other crops. So it means that he can start putting other feedstocks through and still maintain his biogas output and reduce his feedstock costs. And again, this is the return on investment of most recently based on that particular trial. So averaging about £40 per tonne fresh tonne for his feedstocks, and that takes in disposal costs. We haven't included displacement of his chemical additives. As I say, this site has started to reduce his ferric input by half since he started putting the biochar in. And what I should mention before this is that from January onwards, he was actually using activated carbon. And then so even on top of the activated carbon he was using, we can get more out with the biochar. One of the other things that we were very careful of is there's a end of waste criteria in the UK. There's something called the PAS 110, which is an end of waste criteria. So if you want to have that certification, you have to adhere to a number of different criteria within it, one of which was heavy metals, and we were very careful to look at heavy metals because this material goes to the soil, so we don't want to be applying more heavy metals to the soil. If you were to use a biochar, say, based from sewage sludge, you would get some massive levels of heavy metals and you wouldn't be able to use it. And what we found was, because we're not putting a huge amount of biochar in, that it doesn't actually change the PAS 110 specification at all. And thank you for listening. If you're interested in getting in touch, talk to me or Lydia, who's in the audience there.
Merci, Monsieur Vaughan. Y a-t-il de la même manière... Oui, une question?
Not working. I don't think I'm... Okay. This, unfortunately, is going to be in English, so the question will be understood and perhaps not the answer as much. Particle size, you mentioned, was a variable. What would you recommend as a particle size? Is smaller better?
Okay, so now we're getting into IP.
All right, don't answer the question.
Well, no, yes. We did do quite a bit of work on looking at particle size. So if we produce our biochar from a pelleted form and it comes out the other end of pellets, that's not useful for us. So we do reduce the size to a specific size, but yes, smaller, but not really small, not kind of way down. There's a kind of a defined area which we like to be in, but we're going to get either side of that, but the bulk of it is at a certain size. Sorry, I can't be more specific than that.
Devant, s'il vous plaît. Si vous pouvez vous présenter.
Hi, Manuel Ortiz from Rambol. On the digestate, have you investigated other impacts other than heavy metals, nutrients, macro, or anything that you can tell us?
We're not looking at a lot of the other digestate. One of the sites we did work with looked at total carbon within the digestate and found there was no change. So you're probably taking some of the carbon out to increase that methane and biogas, and then that's replaced by the biochar, which would actually just be sequestered in the soil. Really?
Sorry, I'm sorry. Always barging in, David. I know you can throw a microphone at me if you want later, but I think it's important to say that when we sell our product to the biogas clients, we mention that our product will come out within the digestate at the end, and if it happens that they they use this digestate over and over and over on the same land bank, over the years the char will accumulate there. But if they want more rapid results on the soil specifically, they really need to add more biochar to the digestate and at this point we refer them to biochar producers that specialize in the kind of soil enhancement products. So our biochar will always sequester carbon in the soils, but if you want quick yield impacts, you really need to do more. Sorry.
Merci. Nous allons passer à la troisième intervention et après on pourra encore poser des questions. Mr. Casini, j'espère que la traduction simultanée va fonctionner sur la troisième. Je sais que ça a été un peu long à se mettre en place pour l'intervention. Donc s'il y avait d'autres questions après, n'hésitez pas, même s'il faut reprendre certains éléments de la première présentation, enfin de la deuxième présentation, pardon.
As you soon will understand, I'm not native English speaker, so I'll speak slower. I'm David Casini. I work in RECORD, that stands for Renewable Energy Consortium for Research and Demonstration. We are located in Florence. We are a research organization, public, private, no profit. And firstly, I would thank Francesca Tozzi and Giulia Lotti, my colleagues that performed the experimental activities that I'll show you in a while. The presentation is about the CH4R project, nice acronym, that is a Toscane experience in the integration of biochar and anaerobic digestion. So I'll start in brief describing the project, then I would like to show some potential application of biochar in the anaerobic digestion system, and then I'll present you the results of the CH4R study for improving the biogas and biomethane production in the reactor. So I'm David Casini, environmental engineer, and I'm head of the Agro-Bio-Clima business unit in RECORD. Main research activities are for tailored biochar production, agronomic trials on field and in climatic chambers with lysimeters, and of course, anaerobic digestion process and microalgae production plants also. The CH4R project is founded by the Tuscany region in Italy, and it's in the framework of the Rural Development Program in the sub-measure of 16.2. The focus is to study how biochar can be integrated in the entire supply chain around an anaerobic digester, with a particular focus also to the soil and agricultural uses. We are the coordinator of this project. We are the research organisms, and we produce biochar through slow pyrolysis. We have different pilot and demo plants for producing biochar. Azienda Agricola Marchesi Frescobaldi is the farm, a wine and oil producer, so a typical economical scheme in Tuscany. It has an anaerobic digester and a gasification plants, so there's also the test of gasification biochar in this project. The AFAL, they are mainly agronomists for regenerative and organic agriculture, and Orto Biattivo is an organic farm with focus in horticulture. Expected outcomes: the full supply chain, the integration of biochar, starting from the valorization of local organic residue, passing through the integration in bioenergy processes, and the focus on soils. I would start just presenting a typical basic integration of pyrolysis or gasification and anaerobic digestion. And as said before, Biochar is just a word that represents a very wide, different types of products. Different characteristics means different end uses. So, for example, a specific biochar can be used for odor control if mixed with manure in storaging, or if, for example, activated, can be used to filter the biogas for H2S removal. But these are just some examples. Or, for example, we can filter the liquid fraction of the digestate after the separation to reduce the nitrogen emission, because there's a filtering of the ammonium compound. But instead of a filter, it can be used also as a carrier. So we tried to enrich the biochar, charging it with the liquid fraction of the digestate, so to have a nutrient retention and an application to the soil of this material to improve these nutrients' availability to the plants. Last but not least, of course, biochar is used as an additive in microbiological processes, plural, because not only in the anaerobic digester to increase the biogas and biomethane productivity, but also in the composting, for example, to produce a product that I called combi, just because it's a combination of compost plus biochar. But that means that biochar is used as additive in the co-composting process. So we have tried at lab scale to filter the liquid fraction of the digestate using two simple biochar as produced, one from poplar, one from alder wood chips. And the gasification biochar test is still ongoing, but we have already tested as benchmark an activated charcoal, a commercial activated charcoal. And we have removed the 29% of the ammonium in the liquid fraction. That means that biochar can also act as a prevention mean for the volatilization of this compound. And of course, this material is not activated or post-treatment in some way. It's just as produced. We have also tried to put this liquid fraction in this carbon sponge, the biochar. This popular biochar charged 3 times its weight with a liquid digestate, not filtered, because I'm speaking about it because some occlusions can occur. We have increased the nutrient, of course, content of this carrier, and then we have tested biochar alone, enriched biochar, and a control thesis with NPK. And so we can start saying that about supplying nitrogen as macronutrient, we have saved the 20% respect to the control, obtaining what? We have cultivated in series lettuce and tomatoes, and the productivity of lettuce was absolutely the same, using the same amount of nitrogen in all the theses, of course. But in case of tomatoes, as a result, we obtained a 20% more productivity in tomato. And most important and interesting, at the end of this agronomic trial, in the soil where the enriched biochar was present, the nutrient availability to the plants in terms of nitrogen, nitrates, and available phosphorus resulted higher than the biochar alone, and of course respect to the control normal practice using NPK chemical fertilizer. We have also used biochar in this context as an additive for the co-composting process, because it can increase the process quality in terms of maximum temperature reached, the lasting of the process, so the duration is lower, and at the same time the quality of the product is better, because for example in terms of humic acid content are much better using biochar as additive. There's an open access publication if interested in this topic. You can read all the results. So starting with the main topic of this talk, in the past we have tried simple substrates, as you said before, when it's just a bit more difficult to obtain good results because my silage is a very common and simple and easy degradable substrate to produce biomethane and biogas in general. We used just 5 grams per liter of biochar milled at 250 micrometers. It's important not to go lower because you can disrupt the macroporosity structure of the material. So if you use a poplar, probably you have a porosity structure also near the 100 micrometers. So we use 250 for this reason. We use the Angelidaki method with the same instrument you presented before, STM2. Food to microorganism ratio of 0.5 and a temperature quite high, 43, because it's the temperature where the inoculum and this substrate was operated. So we obtain a 10% increase for popular biochar produced with a plant of ours, Pyroc. We have another plant, but without particular results in that case. So the focus was that. Also, considering a quite simple, easy degradable substrate, is it possible to improve the biogas production? Interesting. So we tried a semi-continuous test at lab scale using the same popular biochar, and we obtained something that has to be known in general, that is that biochar may cause an initial upset, of course, with our substrates, with our inoculum in these conditions. But it could be. Of course, then it will be reached a new equilibrium in the syntrophy of these microorganisms. And in fact, when a pH drop occurs, the buffering capacity of the biochar really helped to maintain the process and, of course, increasing the possibility of having a production in terms of biomethane. In the CH4R project, Azienda Agricola Marchesi Frescobaldi uses, in general, quite complex substrates, but these are the substrates that the farm has. Swine manure, pig slurry, I would say, olive pomace from the oil production, grape pomace from the wine production, and seasonally also they put in the digester the olive meal wastewater. Seasonally, not always. We have tested 2 different chars. One from the gasifier of Azienda Agricola Frescobaldi, one from Record, from slow pyrolysis, a rotary kiln, a simple rotary kiln. Differences are quite the same as always. More ashes for the gasification char, and a more developed surface area in terms of micro and mesoporosity, so smallest pores, in respect to the slow pyrolysis biochar. We have taken the inoculum from the digester of Frescobaldi. We have filtered and degassed, of course. We used all the substrates cited before and listed before. We have dried and milled them. We have dried the biochar, of course, milled and sieved at 250 micrometers, and same parameters said before. We have tested, apart from control and blank, of course, 2 different levels of concentration of biochar addition in the digester, and 2 different biochar. Quite stunning results, or not, it depends. The substrate was not so easy, and probably biochar really helped very much, because in the case of the gasification biochar at 20 grams per liter in the reactor, we obtained an increase in the biogas production of about 45%. But in general, all the biochar produced more than the blank. We observed an initial lag phase of about 3-5 days, and of course there was a very high variability of the replicates, even within the blank triplicate. That probably means that there's the substrates are quite complicated and complex in general. It's interesting to see that the biochar from a gasification led to results with less variability respect to the others. And the theoretical production, the Boswell formula equation that usually we use to see where's the limit of what we can obtain is just a formula, but sometimes it's very useful to make comparison. In that case, we are really far from the theoretical results because all these substrates contains olive stones, contains grape seeds, a lot of lignin content that is not easy to be degraded in the reactor. So at the end of the story, Azienda Agricola Frescobaldi can produce biomethane, coupling its plant with a 100 electric kilowatt of power of cogenerator. They use all the substrates they have in their farm, and biochar can enter in this scheme, giving more sustainability to the process, also with a perspective of, as said before, of the use as a biochar added to the digestate, independently that if there's already or not a quote of biochar used as additive in the digester. And interesting to see that there are not differences or in pyrolysis of gasification char in the anaerobic digester. I don't know if you have different experiences trying to compare these two different classes of biochar. In that case, gasification biochar, probably for the more ash content inside the biochar, I don't know, had a really low variability and good results in the digester. Thank you very much for your attention. If you have questions, I'm here.
Merci. Est-ce que cette dernière présentation soulève des questions complémentaires sur le biochar et son utilisation pour optimiser la quantité de méthane produite et d'autres, on voit d'autres également applications et d'autres usages.
Back, Hugh McLaughlin, I'm the CTO of Trinity Biocarbon. So are you satisfied with the levels of characterization available on biochar products from the marketplace with respect to selecting a biochar? My friend, this is not a stand-up comedy routine. This is a legitimate scientific question. You mentioned merely a gasifier char versus a slow pyrolysis char. That's kind of like saying a potato versus a hunk of meat. What do you look for, and how do you find it?
Thank you for your assist. No, we are not, of course, satisfied about the biochar characterization, even in scientific papers, I would say. For the agronomic topic, it's a disaster. We say just biochar, but as said before, I'm a human, you are a human, she is a human. We are quite different, I would say. And so it's the same for biochar. Without a porosity characterization, you don't know what product you have in your hand. You can't know. So the porosity is not just BET, surface. It's also a matter of macroporosity. So probably a mercury intrusion porosimetry is something that should be more than suggested, should be mandatory to characterize your product. It's my opinion, of course. So it's the same about the particle size when you're going to use your product. In the macro category of biochar, there's of course pyrolysis biochar and gasification biochar, probably hydro biochar, and they, of course, the people should be aware of the differences of these products. Both are interesting, very interesting. Both can be used with a lot of applications, but they are different.
If I could just augment that, I would urge every biochar user to retain a liter of the material when it first comes in, put it in a sealed canning jar like you would storage vegetables, and put it on a shelf. Because if it doesn't work, you want to see what was wrong with it. If it does work, you want to see what to look for the next time. But without that retain, you are losing the history on the material after it goes in the field. So just take a liter, set it aside, and you'll have recourse, and then you'll build up success.
Remembering that biochar is a biochar only when its characterization following the EU fertilizing product regulation says that there are no harmful compounds. Remembering that then it's biochar, not before. If there's an harmful compound, it's just special waste.
Oui, une autre question.
En français ou en anglais? English or French?
Bonjour, merci déjà des retours d'expérience. Rémi Chalmandrier, entreprise Opus Énergie, je fais du conseil en biologie pour les exploitants.
Sorry, I'll anticipate that I need a translation because there's no an English version of what he's saying, and so
I can make it in English also if you want. Okay. So I'm Rémi Chalmandrier. I'm working for Opus Énergie. I'm a biologist for anaerobic digestion plant in France.
Attendez, alors du coup, il faut mieux qu'il pose sa question comment? Parce que là, il est en train de changer la traduction, mais il doit parler en français ou en anglais?
I did a mess, my fault.
J'avais une question sur les perspectives pour des méthanisations qui ont des rations fibreuses. Parce qu'en fait, vous avez beaucoup parlé d'installations qui ont des taux d'azote assez importants ou des taux de soufre assez importants ou des instabilités d'une manière générale. Qu'en est-il de modèles avec beaucoup de rations fibreuses, avec beaucoup de fumier? Je ne sais pas si vous voulez que je la fasse en anglais.
Do you understand? No.
What about the biogas plant with a high amount of solid manure? What about the degrading better the fibrous material? What you explain is that you have a lot of positive experience with biogas plant with high nitrogen content, high sulfur content, and the one which are unstable with high volatile fatty acid. What about a stable plant with high fiber, which we have difficulty to degrade the fiber?
Yes, probably it's something that you have presented before in your presentation.
Yeah, so a couple of the sites we're working at the moment, we're looking at high chicken manure, so there's high nitrogen fertilizer inputs, and also we're looking to work with sites with high sulfur content. We are seeing a drop in sulfur content, H2S in the gas in the sites that we are working with, and we're also seeing a drop in ammonia with the sites we're working with as well. The fiber content, some of the sites we worked have high using solid manure as well, and we're seeing an increase in biogas out of those. So yeah, it does work with all of these sort of things, but in sort of kind of various different ways.
Et je voulais rajouter, nous c'était certes en labo, donc avec des petits volumes, mais le digestat que l'on récupérait, c'était très riche en fumier, parce que les bovins étaient sur paille.
C'est un élevage de taurillon, donc beaucoup de fumier, beaucoup de fibres dans le cas qui a été présenté, effectivement.
Hi, so I've got the question to Italian guy, sorry. It's very interesting, it's really nice. We obviously try to do a lot of research on our own in the labs, yes. The problem started when you start translating the dosage to the full scale. and the economics of it. Yes, so you were dosing 5 grams per liter. If you translate it to a 3,000 cubic meters digester, there's a huge volume of char that would give the results. So we were trying to find the happy medium, you know. We know that if we keep pumping the char into the digesters, they will eventually reach the potential 48-25% if there is enough to squeeze from the feedstock on the front end. So in your view, like you did, maybe 25 is not needed, yes, to give economic value to the client. When would be the kind of a, when did you start already? Because there is the concentration increasing. Like, what would be the lowest you would feed to see the results in consistently on the kind of a lab scale and full scale trial?
In that study, we started from a mass balance of what the gasifier of Azienda Agricola Frescobaldi daily can produce, and on the size of the anaerobic digester they have. And 5 grams per liter means using all the biochar produced by the gasifier that today is stored, sometimes used to be put in the soil directly as a soil improver. In this case, we simulated the completely using all what they have. So that's the reason why I have no data in that case with a concentration lower than 5 grams per liter. We have tried also 1 gram per liter, no less. I have no experience in less than, okay? But it's very interesting how so the next step, it will be put their biochar inside the anaerobic digester, because they have a pool for storing all the digestate they produce. And so in this pool, there will be all the biochar added as additive in the digester. Probably the problems will be if this biochar will settle in this big pool before the soil application. So it's not a matter of economics in that case, it's a matter of using all of what they have, and it's an interesting scheme in that sense, but I agree, different from a commercial perspective. So we started saying what substrates you have, which is your plant in terms of gasification, anaerobic digestion, production, and so on. 5 grams per liter. That's an unusual, really, I agree. That's an unusual, but quite common in Italy, because after 2K, there were incentives for electric generation and production, and there are a lot of gasifiers, not only in Tuscany, but in general in Italy, in farms. Some of these farms have anaerobic digester, and biochar can be applied to soil, but before can be used. And that's our role, trying to see if it's possible, and with some interesting results. In that case, yes, there are.
Très bien. Est-ce qu'il y a d'autres questions? Oui.
Good morning, Mr. Vaughan. I arrived a bit late for your conference, sorry. I was just curious about the creature. I was just to know if it's a process or is a product for increasing production of methane.
So Creechar is a product. It's the biochar product that we're supplying for anaerobic digestion.
Thanks.
Très bien, pas d'autres questions. You stay a little bit here? Or... Nous pouvons terminer la conférence, mais les conférenciers peuvent répondre à quelques questions complémentaires si vous souhaitez les voir. Et sinon, je vous souhaite une bonne suite de salon et un bon appétit. Merci.